Okay, thank you all for coming today. I will also present my final presentation today of my 10-week internship here at JPL. Yeah. So I would like to start to give you some information about my educational background. So I started my studies of mechatronics in Austria at Johannes Kepler University in Linz in 2011, and I completed the mechatronics studies, the undergraduate studies, last year. Then I came here to Northern California for an exchange semester at California State University with a major of computer science, and currently I'm studying in Austria at Johannes Kepler University again, and I'm doing my robotics major there. Okay, so let's have a quick look on my tasks. So I had two big tasks to complete during my internship, and the first task was to develop a timeline database plugin for Cameo Simulation Toolkit. I'm sure most of you know, but Cameo Simulation Toolkit is a no magic plugin, and you can simulate models and generate the simulation data. Yeah, but I will go in detail on this later on. And my second task was to develop a MagicDraw AsciiMathML Constraint Editor. So AsciiMathML is a math language which just uses ASCII signs, so it's really easy to use and it's quite convenient, and we will also see that in more detail. Okay, so let's start with the first task, the timeline database plugin for Cameo Simulation Toolkit. What was the main idea behind this plugin? So right now, if you're simulating some data with Cameo Simulation Toolkit, the data will be stored directly in the SysML model, which means that the more data you will store, or the more you're simulating, the model will grow, and we want to get rid of that. And you have to use Cameo Simulation Toolkit for the visualization, and yeah, there are limited options. And yeah, so the purpose of this plugin was to store the CST simulation data in a database. In this case, I'm using ElasticSearch, which is also used by Google and Facebook. And so we can separate the simulation data from the model, and as soon as the simulation data is in the database, we can use other tools for visualization like Kibana or Grafana. And I will do a quick demo today with Grafana, which you have already heard about it. Okay, so let's have a quick look at the architecture of the plugin. First of all, I'm using the MagicDraw Open API to load the plugin. I think I'm right here. And the MagicDraw Open API calls the Cameo Simulation Toolkit Open API, which then creates an event listener. And with that event listener, we can listen to any value changes within the model. And if there are value changes which we want to record, the event listener will put the data into a queue. And the inserted data is, I called it transfer data, and it contains the name of the value property. Then it contains a timestamp and the actual value of this property. And it contains the simulation session in which this value was changed. Okay, so then I'm using a thread to get out the data of the queue and do the REST call and put the data to the ElasticSearch database. So I'm using the thread here because otherwise, if I would directly do the REST call through the event listener, the simulation would get delayed and would yield some bad data. Okay, and as soon as the data is in the ElasticSearch database, we can now use Kibana or Grafana to visualize it. And Kibana and Grafana, I forgot to mention that, but we already heard it. There are way more options to just visualize, and they're really nice tools. Okay. Yeah, so let's do a quick demo of the timeline database plugin. Okay, so you can see a MagicDraw model here, and we have one block here with, which owns two values, power and power1, and we now want to listen to value changes and record value changes of these properties here. So I created a small activity diagram, which you can see here, to just provide a change of the values. And you can see the power value will increase by 1 after each second, and power1 will increase by 2 after each second. Okay, so, and in addition we also have this green block, which is provided by Cameo Simulation Toolkit, and it defines all the variables you need to set up your simulation. So it's the simulation configuration. And you can see there is, for example, the execution target, which is P, which you can see here, which we wanted to execute, and the start time from the simulation. And so the upper part here is provided by Cameo Simulation Toolkit. And then in addition, we applied a stereotype called timeline configuration to this simulation configuration, where now we can define our element list, means the elements we wanted to record, which are in this case power and power1, and you can define the URL. So in my case now, it's the URL of the database, and in my case I'm running ElasticSearch locally on my machine, so it's localhost, but yeah, it's just the location. Okay. Yeah. Have a look. Okay. Yeah, so we're good to run it now. Okay. So here you can see the simulation running. And I hope you can see it, but the values here, they are changing. So let's just wait for a little while to get some data on the database. Okay, then we can stop the simulation again. And so now we have put the data into the ElasticSearch database, and we are ready to use Grafana to visualize this data. So yeah, that's Grafana. So the first thing to do is to point Grafana to the ElasticSearch database, which can be done by here in data sources. And you can see I have already set ElasticSearch to my default database, so we just choose that, and we can save and test it, and it should work. Okay, the test is successful. So we can now go on and add a panel, add a graph. It just takes a little while. So you can see it's loading up here. Okay, so what we can see now is one panel, and on this axis you can see the timestamps. And on this axis there is the count of how many how many data points were stored to the database at a specific time. So we are looking just at a specific time range now, and we can zoom out here a little bit. So to find our data, I posted it way back.
Isn't that the Voyager epic?
Yeah, that's the ISO format. So okay, so you can see a peak here, and we can zoom in here a little bit. And finally, you should see the single data which was posted. Yeah. So now you can see there is data was posted every second where we did our value changes, and on every second there were I think you can see it. There were two values posted. Okay, so now we can go on and actually visualize the values. So we add a query, we switch from count to average, and we can select the field. And so I think here you can see now the power and power 1 field, which we wanted to record. So let's take the power for now. Okay, and you can see it's starting with 17, and it's increasing by 1 after every second. Okay, and we could add another. So we add another property, select field. Let's take property 1 now, power 1 now, and that should be way steeper because it's increasing by 2 after every second.
So those are the actual power values?
Yeah.
Okay.
I mean, it's
so the green line here basically is performance data on the database itself, right?
The green line just displays how many data was posted.
Right. You're just showing the post over time.
You can have lots of metrics of how many you post, the average, the standard deviation.
So there is a lot of sophisticated stuff to do. It's really good. Okay. Yeah, that was the quick demo of the timeline database plugin. Are there any questions about that so far?
So can we tell it not to interpolate?
Because
I mean, those are discrete.
Yeah,
values,
absolutely.
right?
Yeah, there should be.
Whatever went wrong with interpolation?
I think. Yeah, I think
Power was 2.5 then.
I'm sure you can do that. I will have to look in that after.
Okay.
Yeah. Some of this was a bit serendipitous. I think as we started to look at Trish's study, we were like, hey, this kind of stuff looks familiar, right? The computers we fly in space have similar metrics as the computers we operate on the ground. So he's actually testing out the technology she was talking about now. So,
Curious. Did you consider using the TMS the tool we are developing to store time usage data?
Yeah, I couldn't use TMS because
He's foreign national.
Yeah, I'm foreign national, so we choose to demonstrate that with ElasticSearch.
Okay.
Yeah.
But Grafana allows you to write plugins and database connectors. You can integrate in any kind of database behind the scenes.
Implementing TMS to connect with, okay.
Yeah, that would be
So I think you had a question, Elise?
Yeah, I still want to know how you use it.
Yeah, oh, that's a great question. So,
This is great, but
Yeah.
I'm curious as to how
Yes.
you're going to use it.
So the impetus for this was to discover kind of a better way to understand what's going on with all the systems in CAE. Obviously, CAE has made a big change from just being desktop tools with license servers to being these web-based services. And coming along with that, of course, are users that immediately notice if there's a problem and want to know what's going on. So we want to know, too, and even be able to see possibly even earlier just what the health of the overall system is and if we should start anticipating problems and so forth. So that was the impetus for the study. I think once we got to the technology part, and even somewhat in the design part, we noticed that this stuff might be relevant for analysis as well. So our plan is to look into implementing this against the CA systems like Trisha designed, and I think we're open to making that data available to the users, provided they don't make matters worse by using it, like pulling the refresh button on multiple browsers or something like that. But I think now that we've looked at how it can be used in analysis, we're talking with the TMS guys for how we can combine this with the TMS offering as well. So, because obviously a lot of these open source visualization capabilities are pretty robust, and they would make a good complement to what's there. So, yeah. And ElasticSearch is just proving to be an incredibly powerful technology across the board. So, is that a good draft answer?
Yeah,
Okay.
for sure.
I think as you saw that you have to be careful with Elasticsearch in the way that it does its averaging, et cetera. And
Yeah.
whether it starts to give you wrong
Right. So I think that's where the TMS API can come in and help us, because TMS API has a lot, or Timeline API, however you want to call it, has a lot of thought into those semantics and stuff, and will help us drill down on that. And I think that, I think kind of thinking in the CA infrastructure space, it will help there too. We want to leverage that kind of precision there as well. So I think probably the big thing that was missing so far, at least, we found, is that state timelines it doesn't have.
No,
so we'll have to add a
but
plugin.
I assume you can write a plugin and then interpret the data accordingly.
Right. So, but
It's a very open platform.
yeah.
Okay. Yeah. So.
We're moving right along.
Future work. So yeah, some things have already been mentioned, like implementing listeners for state changes in state machines. So, and also writing a Grafana plugin to visualize those state changes. So it will be cool to have one graph where you can display the, for example, the change of the power consumption with the change of certain states. And one last point would be to evaluate and optimize ElasticSearch as a timeline database. And maybe you could also have TMS down here. And yeah. Okay, so that was my first task. Let's go on to my second task. So my second task was to do a constraint editor. What was the main idea behind the constraint editor? Currently, if you're editing or creating constraints in MagicDraw, you have the constraint blocks, and you will have to click on the constraint and open the specification and create an expression and create another element value and go through all of these steps and building this tree. And that's not really convenient, and you can't see the whole equation at once. So the purpose of this plugin was to facilitate editing constraints in MagicDraw, to, as we heard, create and edit constraints in the constraint blocks in just a more convenient way. And this will be done in AsciiMathML. So it's, as I mentioned before, just using the ASCII signs, and it's a quite easy process.
I want to add one thing to this. I think this is also a pathfinder for how we're going to do expressions on View Editor. So what you see here, you can get a little excited about how it might work on the web as well.
You've given up on LaTeX? Come on.
No comment.
Okay. Another point is with the editor you can store these mathematical expressions now as UML expressions or as UML string expressions. So I think most of you will know the UML expressions. They look like, so you have in the constraint you have element values, and in between those element values you have commas and you have some parentheses. And with the UML string expression, you get rid of all those unnecessary commas and parentheses, and you can so just copy the constraint and paste it to any other kind of math engine and to solve it. So that would be quite convenient then. It also supports to save it as an infix, in an infix and in a prefix notation, and the editor will render the expressions for a nice lookalike. Okay, so it's hard to see right now. Yeah, that's better. Okay, so let's have a quick look at the plugin architecture of the constraint editor. So the first thing I did was to define my language. And I used the Antlr tool for it. So Antlr is another tool for language recognition, so some of you know that. And I defined my grammar in the Bacchus-Naur form, and then I used Antlr to generate my parser. Okay, so I have my parser here, and then I used the MagicDraw Open API again to load the plugin, which we'll call the graphical user interface, which I have written in Java Swing. And then you're ready to enter your constraint. Hit confirm, and the new expression will be put to the parser, which then will parse the ASCII string. And this parser will provide an abstract syntax tree then. And since then there are two options now for the user. So on the left, you can see the user can choose in between saving the constraint as a prefix UML expression, or here on the right, he can save the constraint as an infix UML string expression. And the third branch here describes the rendering of the expression. So I'm transforming the AST into a mass modeling language, which can then be rendered to a picture to have a nice lookalike. And this branch is all done with the Reno engine, so that's a JavaScript engine which is entirely written in Java. Yeah, so the blue part here is how to create a constraint, and since you have saved it then as a prefix UML expression or as the infix UML string expression, you can edit one of those, call the MagicDraw Open API again, and create the ASCII string again out of the tree structure here, so that you are able to easily edit the mathematical expression. And that will be displayed in your GUI again, and yeah, you can forward the edited expression then again to the parser. Okay, so let's do a quick demo of the Constraint Editor as well. Okay, so what you can see here is a MagicDraw model with some example constraint blocks, which I created. So I have some already existing constraints here. I have some parameters here, and yeah, so there are just 3 constraint blocks. And here are 2 really important blocks. So you will need to have those blocks somewhere in your model, because this block, the AsciiMathOperator library block, defines all the operations you can use. So they are also defined in the grammar. And in this block, the user can store user-defined functions. So the custom function block. Okay, so let's do a quick example. So on a right click on the block, you can now call the Constraint Editor here. And here you can choose in between creating a new expression or just editing one of the 3 existing expressions. So yeah, let's just say let's edit example 1 here. We can choose example 1. And yeah, so that's the Constraint Editor. Here at the top you can see the text field where you can enter your constraint. And in the field below you can see the rendered expression then. And in this field here there are the operands are listed. So these are the operands which are defined on this block here, so which you can use to create the expression.
When you get back.
Swipe down with 4 fingers.
He has only 3.
Nobody in The Simpsons can use it. Just mash your face into the keyboard.
Okay, so yeah, we could just, for now, just add something to it, -f. So you can confirm it, and you see it changed in here. And so, as you can see, this this constraint down here is now saved as an infix, a string expression, and you can change in between a prefix expression, like hit confirm, and you can see it changed in this prefix expression. Yeah, so let's try to create a new expression. Just hit here, so everything is empty now, and you can take gamma.
So operations and operands, it's picking off of the parameters and the parametric block? Okay.
Oh yeah, I forgot to mention the operations, I think. So the operations which are displayed here, they have to be defined in the AsciiMath operator library here and in the custom functions.
Okay.
So you can see all of that, and on the bottom you can see the function matrix and Antlr.
Yeah, I got that, but I was curious. The
operands.
parameters are showing up from the parameters on the parametric block?
Yes.
Okay.
Oh yeah.
And gamma
Yeah.
and F.
Yeah, they are from here.
I got a
You can
question
type
here.
as well.
You can just type it in instead of putting it in.
Yeah.
Yeah, absolutely. So we could, for example, let's take square root of alpha, and let's say we want to save it as an infix string expression again. Confirm that. Oops. And yeah, so you can see you have your gamma plus the infix string expression right here.
So you got spell check too?
That's the wrong one.
Okay.
Yeah,
Oh,
no, because it's a grammar.
yeah.
So when you enter something wrong function, wrong operand, it will create a
Yeah.
parse error.
Good.
And that should be, could be auto-completion as well, right?
Okay. Yeah, so that's.
Can you show the spec window on one of those so we can see what it looks like?
Oh, yeah.
So-
It's using the underlying expression structure, tree structure?
Those, for example. So
Yeah, so it's an actual,
open specification, and you can see here it's creating this UML expression, the tree structure here. You can go in here, and it's referring to all the element values.
so we could actually index it and search all the expressions that are using a certain parameter.
Yeah.
Might be useful. Maybe.
Remotely.
Okay. Yeah.
Switch
so
computers again.
fun.
You have to switch computers again for your
Yeah.
presentation.
Does it save the image representation of the equation as well, so we can harvest it
That
and
could be
document?
one extension. Doesn't do it.
Doesn't do it yet.
Yeah.
That'd be handy, yeah, definitely.
But it's possible in the constraint you can store it in MagicDraw as an image, so you
Yeah.
can just persist it in the model.
Yeah.
Good, you already got it.
Yeah.
Okay. Yeah. So that was the demo of the Constraint Editor. Are there any questions? So, yeah, then I would go on with the presentation. Okay. Yeah, let's real quick just discuss some future work on the Constraint Editor. So it would be nice to add a drop-down auto-completion menu for the text field, so it would work like in some IDEs. Then there would be one point to reuse the element values, which means when I'm editing the constraints right now, I'm deleting the values, and then on saving the constraint, I'm creating all the values again. So, which takes some time, and it would be better to take the existing element values and put them into a pool, and then reuse them on when you are adding a constraint. So, yeah. And a third point would be to support value properties as operands on blocks. So for now you can use the constraint editor on constraint blocks, but it would be good to also use it on blocks and also use value properties as
so
operands.
is it now, so it's limited on terms of where you can apply the expression then, I take it? There's lots of places I can put expressions in the
You can
model,
apply,
right?
well, you can edit it at the moment only in the constraint block because
Yeah.
it looks for the constraint parameters as your operands. Right?
But you can
So it can't
apply
have
it to
simple
any
constraints
blocks.
either?
No.
What about?
That's a limitation.
This is also consistent with the behavior pattern, so.
Well, I'm not disputing that, but there are other places we'd want it to work too that may also be consistent with the behavior pattern. What about dimension analysis? Can you reference the value types, units?
No, it's not supported.
No.
Make a Jira ticket.
For next summer, so
Well, I'll have to wait till then, but yeah. No, this is great stuff.
So looks like MagicDraw supports
Assigned
expression 3 out of the box. I didn't realize that. That's
the constraints.
constraint.
The
The UML expression.
Yeah, the
That's
UML
the UML feature supported by MagicDraw. So both things, the string expression and the UML expression.
Yeah.
So I guess actually I can manually edit expression 3
Yes.
and then okay.
But
So
it
I
will
guess-
be old and gray when you have done it to
So
finish
then,
it.
does the Cameo Simulation Toolkit support expression 3?
It supports string expressions. That's why we support both. Because you just need to convert it to a string, and then the same Cameo Simulation Toolkit will work.
Right.
Yes, it does.
So I guess expression 3 actually that helps in, for example, if I delete a constraint parameter, then we can easily check whether that expression 3 is consistent with the set of parameters. If that string actually is harder, we have to parse the string.
Right.
So things like that.
That's actually a good point. Is it going to show those errors in the validation window? If you
No, but we could easily create that because we have the parser, right? So the parser is a grammar, so we can parse it and generate validation errors.
that'd be really cool.
Well, getting back next summer.
No, you're gonna wait that long.
Okay. So that's the end of my presentation. Thank you all for your attention and for the challenging and awesome experience here at JPL. Thanks to Robert, to my mentor, and to Chris, and to all of you guys for all of your help. It was an awesome experience here. Thank you.